Presentation, indeed. Can I have another round of applause, please? Okay, moving on. We have the pleasure of having with us here today Mr. Michael Scott from Babcock International, LG Sales Manager, presenting us today about innovation in the conservative industry. Okay, Michael, the floor is all yours for the next 15 minutes. Yeah?
Thank you. Good morning. Thank you very much for having us. It's a great opportunity for us to tell you some of the exciting stuff that we've been working on and are looking to work on in the future, and particularly what being part of Babcock has meant for us in terms of innovation. So I'm going to just take you through a brief intro of Babcock. Some of you may be aware of them, but some maybe not. And then I want to talk about our LPG solutions, what we've got at the moment and what we're looking to do in the future. And then I want to talk about our continual development efforts as we move into the changing marketplace. So Babcock International are one of Britain's largest engineering firms. We're headquartered in London. We have an annual revenue of about £4.5 billion. We have over 34,000 people globally. And we cover a vast engineering offering throughout the world, and we manage a lot of assets. We have four main groups: marine and technology, which is where LGE Process sits, defence and security, support services, and international, which is everything that's outside of the UK. Marine and technology, until recently, has been heavily focused on the armed forces. We build the aircraft carriers, submarines, nuclear submarines, and recently branched out into more commercial things, which is where LGE come into things. Defence and security focuses on the armed forces. We manage all the ground personnel vehicles and aircraft. We maintain all the hangars globally as well. Support services is all our infrastructure. We do rail, construction, energy, power supply, and our international is everything outside the UK, and that breaks down to simple things like DAF vehicle supply. So we're vast and we cover a huge demographic. So in energy and marine technology, where we sit, we have a marine design team, naval architecture. We have our gas handling systems. We also provide asset integrity, fixed platforms, floating platforms, FPSOs, and we also have production engineering, which is the naval architecture, and do commercial and onshore as well. Babcock, where LG and Babcock have managed to leverage off of each other, is the marine engineering and design. Babcock have been involved in a lot of the feed studies for some of the big projects. We can see the Prelude here, so we're involved in early stage feed, checking feasibility, and by using that knowledge that they have and bringing it into LGE, it's allowed us to broaden our horizons away from our core products, which are the LPG gas handling systems. So Babcock LG Process was founded in 1967, and we've had various guises or disguises since then. We were part of the Weir Group until the recent takeover by Babcock, which happened in 2012. We're engineering, procurement and project management of gas handling equipment, mainly focused on LPG and moving into now LNG. We've got 60 current projects in LPG, mainly in the shipyards in the Far East, China, just came online, as well as Korea and Japan. We are based in Edinburgh in Scotland. We've got about 130 personnel there now. We've got 16 in Korea, and we've just moved 2 recently into China to service that new emerging market for us. We also are heavily backed by Babcock in innovation, so we have a number of patents pending through Babcock's IP company. And I just want to take a minute now to talk about where we are with LPG. So we're in the middle of a growth period. We had 233 billion in the LPG market, and we're looking to grow to 300 billion by 2020. So I think it's really important that we're all on board and we're doing everything we can to keep that momentum up and reach the 300 billion as efficiently as we can. We know it's a well-established market. We've been doing it for years, and we're pretty good at it. So how we're approaching our innovation is we don't want to change too much from what we know works. Well, let's just look at novel ways of changing the application of what we're doing and look for ways to improve on that without straying too far from the beaten track. Obviously, as we go through this growth period, there's a number of key drivers: cost savings, the government offering up some money for a change, and there's also the global emissions regulations, obviously the most important one. Again, I want to emphasise we're not looking to be a game changer. We're looking to enhance things that we know and we can do well, and use innovation in novel ways. Again, we need to try and maintain a market-leading position, and we have to try and keep ahead of the game in that respect as well. So in LPG, we have a number of novel applications, a slightly different way from the traditional way of doing things. Some of you may be aware of it. So we have the vent gas cooler, which has two modes. We have a coefficient of performance, which helps us improve efficiency. And we also have our volatile component mode, or incondensables mode, as we call it. And on the back of those systems, we've developed a supercooler, which has a bit of a twist on the vent gas cooler technology, and we use that for the ethane market. So a quick overview of the vent gas cooler in coefficient of performance mode. So we have our 3-stage compressor, and traditionally we'd go through all the compression, and we'd have one economizer. We had a light bulb moment, and we've tried to introduce this second economizer. And obviously that allows us to introduce a second stage of subcooling between the second and third stages of the compressor, and we can get more condensed propane for the same utilities. So the same compression and the same seawater requirements, everything stays the same. It just allows us to get higher throughput. We grow on that, and we move into volatile component mode, and that reintroduces the vent gas separator. And what this allows us to do is handle a higher ethane component of the propane, as well as only needing to vent our nitrogen to air. So on the back of that, we've looked into moving into the ethane market, as it's obviously a growing market. So we've developed a supercooler. Works along the same lines as the vent gas cooler, and in here we've got the supercooler. It's a direct expansion heat exchanger, which we place after the economizer, and by the same token, it allows us to handle a higher methane content without the need to increase the compressor discharge pressure. And again, we can add the VGC mode to it, and this reintroduces the vent gas separator. A slightly different configuration on the heat exchanger, and we can handle up to 3% mole methane. So looking to the future, just wanted to run through a couple of the things that we're working on just now. We've put in a strategic projects team with the backing of Babcock, who focus on things that are not quite blue sky, but taking different technologies and using them in novel ways. And we're working on LNG reliquefaction, regasification. We're looking at some crude oil transport to help with new emissions targets, and also our ethane, ethylene reliquefaction is part of that as well. I want to touch on what we call the FGS-V0, which is the fuel gas supply vessel. It's a patent pending technology for the first zero emissions small fuel gas supply vessel in LNG markets. We've worked very closely with a customer that we've known for years, and we're looking to have a joint offering to market in the very near future. So in this, we take the boil off and flash gas from the transfer operations. We compress it, we put it into storage, and it's in storage until we need to use it as fuel. We can obviously scale that up or down as is required for the specific vessel movements, and we can also use it to condition the receiving vessel by increasing the storage capacity. This is just a brief overview of it. So from the cargo tank, we take the boil off gas, pass it through the compressor, and put it into storage. It then sits there, and we can put it through the pressure reduction and heating, ready to use with the engines for propulsion and electrical power. We're also working on tank C designs, again heavily driven by the cost implications. We've developed in-house software which has allowed us to, for example, lower the amount of steel needed for a 20.6K semi-refrigerated LPG ship by 400 tons, so it's not insignificant. And finally, we're looking at LPG as fuel. Like my colleague, we've developed some software and we know the process equipment that's required, and we want to just ensure that we can offer this, and it's not too much of a capex investment required, so that we can have LPG on the back of our existing reliquefaction system. And that's all from me.
Thank you very much, Michael. Do we have any questions from the audience, please? Is there a question? Sorry. Yes.
And thank you for the presentation.
Sure.
And in the last page, you have mentioned that you have developed a new software for the cargo tank design, and you can reduce the tank weight significantly.
Yes.
And as you know, I want to know how can you to do it to reduce the tank weight for Type C.
We're doing a lot of finite analysis. We get the guidelines which have specific thicknesses at certain points, and what the software does is ensures that we stay within the boundaries at the specific designated limits, and we can strip off material using finite analysis at hundreds of thousands of simulations at various points in the tank.
Yes, as you know, the Type C tank design is, from my understanding, is quite certain, as you know, to fulfill the requirement of the compression vessel code and the requirement for the class. And do you have get the class approval for the new design concept?
Yes, this is all run through class. We worked in conjunction with them at various stages throughout the software development to make sure that we ticked all the boxes in terms of required thicknesses, pressures at certain points as well.
Yes, and do you have any real case project for the new tank design?
Not at the moment, but we are at market with the reductions at the moment.
Okay, it's quite interesting.
Okay.
Thank you.
Okay, thank you very much, Michael.